Hey guys, welcome to mathspays.com. Today we're looking at linear simultaneous equations, focusing this time on elimination. This is lesson 2 after the first one, which we worked on the substitution method. So by now we should know a little bit what simultaneous equations are. I'm going to look at a particular example, something that looks like this. Let's say x plus y equals, we'll go up with 6. And then we're going to say 2x plus y is equal to maybe 10. Okay, now, why is this question different from the questions that I gave you previously? Well, previously, we looked at what we referred to as the substitution method. And that was mainly because when we had them like this. Let's say we had x plus y equals 6, but instead of having 2x plus y equals 10, we had y equals 10 minus 2x, where y was the subject. And because of that, we kind of said it was easier to basically take the y equals 10 minus 2x and throw it in the y above and say that x plus 10 minus 2x equals 6, and then we solve that like we normally would a normal simultaneous equation, well, normal linear equation. X take away 2x is minus x. We subtract the 10 across to make it negative 4, and then we can basically divide it by negative 1, which gives me x equals positive 4. I then threw it back in to make y equals 10 minus 2 times 4 is 8, and then y equals 2, and we've got our solutions of 4, 2. So you can still go ahead and do that, guys. That's no problems. You can solve your question like that. However, when it's set up like this, and what you might notice is, if I kind of put these in columns, you'll notice that the x's are underneath each other, the y's are underneath each other, and the numbers are underneath each other. And that is a setup that we would prefer to use the elimination. Okay, but of course, if you really have your heart set on substitution, you can do it, but there'll be times, and you'll see, where substitution just really probably isn't the way to go. So what does elimination mean? Well, elimination means to eliminate, to remove, to get rid of. Okay. Now, we've seen in the substitution method, the reason why we substitute is because we remove the y's in this particular case, which elimination does that as well. Elimination, though, looks at, I guess, vertically, okay, at removing letters. For example, we can add or subtract things. So if I simply, like, let's say I added the x's, I'd get 2x plus x is 3x. Or if I subtracted them, I'd get 2x minus 1x is x. Okay, but the idea is that we want to eliminate, we want to remove the letters, one of them. Let's look at the y's. What's y plus y? Well, that would be 2y. What's y minus y? Well, hold on. That would equal 0. The whole idea, we want to eliminate, and we can do this by either adding or subtracting. Okay, so it might be better to say, if you want to write some notes down, we want to eliminate one of the letters or the variables or the pronumerals by adding or subtracting vertically. Okay, so it's a bit hard to read there, but it says we want to eliminate one of the letters by adding or subtracting vertically. Okay, which means that we've just worked out that we're going to subtract because that removes the y's. And often what we do, we call like the first equation, the second equation. You might even have more than that. And we write down steps. For example, I might say I'm going to start with the second equation. I'm going to subtract the first equation, which means I'm doing 2x minus 1x. Well, that would equal x. Y minus 1y equals 0. Well, that disappears. 10 take away 6, which equals 4. Look at that. That was a really quick thing to do. Okay, because by subtracting those equations, we got rid of the y straight away and we got our solution. And the reason I did 2 take away 1, I could do 1 take away 2. If I did 1 take away 2, the only real difference will be I get x take away 2x, which is minus x. Y take away y is 0. 6 take away 10 is negative 4. It's still going to be x equals 4, but by starting with the bigger numbers on the bottom, I just avoid having negatives in my answers. Okay. Now, like the last time though, we've only got an x coordinate, so I can choose one of the two equations up here to get my solution. I'm going to choose the top one. Therefore, 4 plus y equals 6. Take away the 4, y is equaling 2. And I've got my solution of 4, 2, exactly like I did for the elimination. Okay, so that's a pretty straightforward method, and of course they do get a little bit hairy. Okay, and we'll look at some of those today. You can add, sometimes you might be having to subtract. People like to subtract. These ones are often a lot easier to subtract, but certainly you can do some adding questions which make it more challenging. We'll have a look at those shortly. Okay, the next question though will be almost identical to the one we just did, so it's not a bad idea for this one, guys, to pause, have a quick crack and see how you get on. In fact, we won't do that one because that's the exact same question that we just did. So let me just hold on for a moment and I'll replace that. Alright, sorry about that, guys. Have a crack at this one, pause it, and then see what you can come up with. Okay, so how did you go, guys? This was very similar to the last one. I'm going to call this equation 1, and I'm going to call this equation 2. Now, if I add these together, like that last time, you'll notice I get 4x, I get 2y. The letters didn't cancel out, so I haven't eliminated anything at all. So I'm going to subtract. I'm going to do 2 subtract 1. Only because the bottom numbers here are all bigger, so I'm going to have positive numbers. 3x minus x equals 2x. Y minus y is 0. 32 take away 12 is going to be, 20. Therefore, if I solve it normally, x is equaling to 10. I'm going to put it back into the top one because it's less numbers there, I guess. X plus 10. Sorry, my apologies. 10 plus y it should be. 10 plus y equals 12. Take away the 10. Y equals 2. Okay, therefore, my solution is 10, 2. Alrighty. The next one's going to be a little bit more challenging though, I believe. Okay. So let's have a quick crack. So that was the one we just did. Okay. Why is this one a little bit different? Okay, I want you to have a look at it. And hopefully you might recognize that the second equation, the 2x minus y equals 1. We've got a positive here and a negative. Now, the quickest thing to do when you're looking at removing letters, okay, is obviously in order to have two letters removed, they have to have the same amount of them. Okay, so I've got 2x and x here. It doesn't matter if I add or subtract those, I'm still going to have an x left over, which means these are the ones that I'm focusing on. Because y and a y somehow will cancel whether we add or subtract them. Now, usually we subtract them, but in this case, if we minus them, right, look what happens. We've got positive y minus negative y. And we might remember that two negatives make a positive, which means we've got positive y, which equals positive 2y. And they haven't actually eliminated. So this is the instance where, in order to get rid of these, we must add them together, because that means we've got positive y plus negative y, which we know that removes to be a negative, and that goes to a 0. Now, that can be sometimes challenging with algebra. If you're not sure, just think, if I got a plus 8 and a negative 8, how to get rid of them? Add them together. Okay, so in this case, what we're going to do, we're going to call this 1 and 2. I've got 2. I'm going to be plussing 1 together. Okay, so in this case, 2x plus x is 3x. Minus y plus y is 0. 1 plus 8 is 9, which means x is equal to 3. I might choose the first equation, sub back into 3 plus y equals 8. Subtract the 3, we get y is equal to 5. So a little bit more challenging, guys, but just double check, okay? Particularly when there's a negative there, just be really careful. If you have two negatives which make a positive, you just got to be double sure that you know what you're doing. Okay. I'm going to start with, we've got two more questions to do, folks. This one, again, is a little bit more challenging, and I wonder if you can recognize why. Well, hopefully you might see that we said before, an easy way to eliminate the letters is find out the exact same amount of letters, because they'll either add or subtract to get rid of or eliminate. But in this case, we've got an x and 2x. They're not the same amount of numbers. I've got y and 3y. They're not the same amount of numbers. So whether I add or subtract these two equations, we're still going to have x's and y's in there. So that's a bit of an issue. Now, you might remember when we have fractions, like for example, a half plus, let's say, a quarter, we can't simply add those together because the denominator is not the same. So what did we do in the past? Well, hopefully you might remember that we times the bottom and the top by 2 to make a common denominator, because once I had that common denominator, now we could plus them together. Well, that happens very similar to this. So what I could do, for example, I could multiply the whole first equation by 2, because that makes, I've got x times 2 is 2x, y times 2 is 2y, and 10 times 2 is 20. But remember, like a fraction, whatever you do to one side, you must do to the other. So you need to times everything, okay, by that 2. Now, I'm going to call this equation 2 and equation 3, only because the top one would be equation 1. What we've now got, you'll notice, is that the x's are the same number of them. So if I add them, we get 4x, doesn't help me. If I subtract them though, we get 0, which is really, really great. Notice I've got bigger numbers in the second equation, so I'm going to do 2 take away 3 this time. So 2x take away 2x is 0, 3 take away 2 is 1y, and 23 take away 20, well, that's just 3. So by modifying that first equation, we've now made something that's really easy to solve. Likewise, we now have 3 different equations that we can sub into. It doesn't matter which one you use, but in this case, the top one, although we didn't use it in our solution, it's probably easy to sub into. So let's sub into it. We've got x plus 3 is equal to 10. I'm going to take the 3 across. We're left with x equals 7, and I've got my solution perfectly. We could use a second or a third one, as I said. Look, if I use a third one, let's just see, make sure it still works. We've got 2x plus 2 times 3 is 6 equals 20. I'm going to subtract this 6 across. 2x equals 14. X equals 7. Once again, you can see that they are the same solutions. I'm going to finish off by saying, therefore, we've got 7, 3, and that's my my coordinate, or my point of intersection of the two graphs. Okay, one last question, guys, and then I promise that we are done. So this is probably the most challenging type, except they're both pluses, so often people like having pluses as opposed from negatives. But why is this one more challenging? Well, like we saw that last question, the x's are not the same, the y's are not the same, but we can't just times one equation to get the other. Okay, for example, I can't times 2 by a normal integer, whole number, to get 5. Likewise, I can't times 2 to get 3. That doesn't work. Now, if you want to start dealing with fractions, I guess you could times it by 2.5, but that just gets a little bit messy. Now, I'm going to go back to these fractions. What if I had a half plus a third? What would we do in that instance? Well, you might remember that we would get a common denominator, but in this case, instead of changing just one fraction, we've got to change both fractions, which means we have 3 over 6 plus 2 over 6, which would then equivalent to 5 over 6, and I could then have my fraction. So this is going to be a very similar method, but this time I'm going to be changing both equations. Now, you have the flexibility, I guess, to either change the x's to be the same. In that case, I'd be timesing the whole first equation by 5 and the second equation by 2. You can make the y's the same if you wish. Doesn't really matter which one you do it. Okay, it will work out in the long run. But I'm going to times the top one by 5, so we're going to have 2 times 5 is 10x, 3 times 5 is 15y. 17 times 5, what's that going to be? 5085. We're going to call that equation 3. I'm going to times the second one by 2. So 5 times 2 is 10x. Hence the x's are the same. 2 times 2 is 4y, and 15 times 2 is 30. I'm going to call that equation 4. Now, because I made the x's the same, you can see that it's just a nice subtraction kind of question. I got bigger numbers on top, so I'm going to do 3 subtract 4. So 10 take away 10 is 0. 15 take away 4 is 11y. And then 85 take away 30. In this case is going to be, what's that, 55, which means that if I divide it by 11, we get y is equaling to 5. I'm going to throw it back into, it doesn't really matter which equation, they're all pretty ugly. The top one's probably easy. 2x plus 3 times 5 is 15 equals 17. I'm going to subtract the 15 across. 2x equals 2, and then divide it by 2. X equals 1. You might want to check your solutions as well, particularly for a really hard question like this. I've subbed into the top one. Let's just double check the second one and sub it back in just to see what happens. 5 times 1 is 5. 2 times 5 is 10. And look at that. 5 plus 10 is 15, so we know we've got the question right. So just like your normal equations, guys, you can sub it back in just to double check that your solutions do work. Bob's your uncle. Look, guys, I know it's a bit of a long lesson there. I hope that made sense to you. Please keep on going through questions in your textbook. Any other help you need, please drop me an email. Otherwise, guys, that is linear simultaneous equations using the elimination method. Have an awesome day.